Hi, everyone. My name is Esme Taylor. I'm the Associate Director for the CAFE, the Center for Academic and Faculty Excellence. Thank you for joining us for our webinar today, Myth Busting in AI, hosted by Brock Dubbels, our guest lecturer for today. I'm going to give you a nice bio for Brock, and then I'm going to pass the torch over to him so he can handle the rest of the presentation. Brock Dubbels, PhD, is founder and CEO of Matrine and an adjunct professor here at Claremont Graduate University in Applied Psychology, where he teaches Psychology 350 UA on designing for AI, with AI, platform use, and the exploration of intelligence. We've included the syllabus for that in the chat if anyone's interested. Trained at the University of Minnesota and a former associate in the Center of Cognitive Sciences, he completed postdoctoral work at McMaster University, editor-in-chief emeritus at IJGCMS. His work has been supported by NSF, Fulbright, NIH, and graduate fellowships. He is the author of two research anthologies on technology and learning. He has led automation work in AI, ML, across healthcare, finance, cloud infrastructure, data science, insurance, retail, subscription pricing, and media intelligence. He also holds two patents in the field of AI. Thank you very much for being with us today, Brock, and we look forward to your presentation.
Thank you, Esme, for sharing that history. It sounds exhausting to say it, but it's fun to do it. And I didn't go down this track on purpose. I was actually at De Anza College doing a philosophy degree at a junior college, and I needed work study, and I wanted to work at the bookstore, and they said, no, no, we don't have any of those left. So I had to drive off campus, which I didn't want to do because I didn't have a car. And they sent me to this place called the Xerox Palo Alto Research Center. And this was my first exposure into technology. And as somebody who's neurodiverse and has difficulty with writing, I had just been exposed to personal computers in our library at De Anza, and I was beginning to think how the difference between having used typewriters, pen and paper, had really changed my experience of trying to express myself. And in the past, I'd really enjoyed doing book reports. I'd really enjoyed all of the creative aspects except for the writing part. And I thought, is this computer actually going to help me to write? Is it going to change the way I think? Will it reorganize my brain in some way so that I can start getting out what I'm thinking about? And that led me into some really interesting pathways to explore. And the first one was at Xerox PARC, where I was working for a PhD in art history, Maya Pindar, and she was the director of the Palo Alto Research Center and at the data center. And our first work was called Data Lib, and Data Lib was actually a title retrieval tool, much like a card catalog, where you used to pull out drawers, take cards, read the card, find the book on the shelf. In this case, it was the first attempt to catalog our millions of titles across the world at Xerox and make them all available to our employees. And this is what led me into UX research. It was completely an accident. And in fact, I went to Maya one day and I said, Maya, this study is so boring that my snoring is waking up the participants. And she says, Brock, how can we make it better? And I said, well, I guess we could make it a little bit more playful. It feels a little stuffy. And she says, a lot of these are kind of stuffy, but as long as we recognize our bias, it's fine. Because really what we're trying to do is find out, are there three ways that we can find each one of these titles? Three different retrieval processes. And I said, that's kind of like Battleship. What if we make it kind of like when you hit three, you sunk a battleship, and then we kind of laugh or make a sound. And that kind of led me along the lines of games, play, and automation. And play for me is our natural inclination towards learning. And games are a structured form of play. And in many ways today, I hope to utilize those principles in our session today as a workshop to work together to discover some of the principles that I found very compelling in the use of AI in the form of automation, excuse me. I just made up a word there. Um, And hopefully you'll enjoy this as much as I have in participating in my own creation with other folks. So this workshop surfaces hopefully what we think we know, fear, hope, or assume about AI and human intelligence. And we begin with what is already alive in the room, and then move to what we want to know and end with what we learned. Is everybody on board? Great. So what I'd like to do is break us. How many do we have today? We should have, let's break.
Excluding, yeah, excluding the two of us, we have 11 people right now.
Okay, so let's break into groups. Actually, I don't think we have to break into small groups. Let's just go with what we have here. And that way we don't have to ask each group to record independently. So what I'd like us to do is begin looking at the seeded claims, beliefs, fears, hopes, and assumptions, and begin to place any of these. Just copy and paste. You can right click, hit copy, right click, paste, and it will go right over here under no. And the idea is this is something that I know. This is something that I fear. This is something I hope is true. This is something that I assume. So what I'd like us to do now as a group is to go through this Aqua board here and begin to gather some of these different seeded claims and begin bringing them over into what we know. And along with that, you can begin to create your own things that you know that may not be available here in the seeded claims. If you need further instruction, and sometimes, like with me, hearing it once does not guarantee that I understand. So I've also written it down here on the left-hand sidebar so that you can read it to feel sure that you're doing what it is that we're here to do, which is to gather what we know about the current state of AI. Shall we begin? Okay, so if I prompt it well enough, an AI will give me the right answer.
Yes, that I assume.
Most of the time.
Most of the time. It's conditional then.
Depends
Yeah.
on the answer. Depends
More
on what
detailed prompts, more detailed prompts always produce better outputs.
No.
No?
Yes.
Yes.
No.
No.
Yeah.
Interesting. Good.
Depends
If
on
I
what the
say
details
be,
are.
if I say be an expert, it becomes an expert, and I can trust the output more.
No.
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 I think sometimes if you tell it what kind of expert to be, sometimes that helps a little bit for me.
Sure. If it sounds like a professor, it understands like one.
No.
No.
No. Sometimes it just pretend.
Mhm. So what this is getting at is what AI is very good at, and that's called coherence. Is everybody familiar with that term?
No.
Coherence is one of the most important principles in AI, and that is when it delivers an output, it should be coherent within that output. Much like when I answered you a question, my answer should be coherent. So in other words, I don't say things like, red bottle makes good dog food earrings. That's not coherent, is it?
No.
Nope. So coherence is one of the most important things that an AI does. But coherence does not necessarily make it true.
Right.
Can anybody think of examples of that? Has anybody ever been in a boardroom where somebody is very charismatic, persuasive, an excellent speaker, very fluent, and immediately the room begins to trust them?
Yep.
Yes.
Has anybody ever asked that very charismatic person how it is that they came up with their ideas and what evidence supports it, and then found that there's none? So this is what we call coherence. And oftentimes coherence is a surface or lexical level presentation, right? So when we say, if I prompt it well enough, it will give me the right answer. That's conditional, isn't it? What's it conditional on?
The quality of your prompt. No?
In some ways, but it's really the quality of the data set that you've
Oh,
retrieved
yes. You're
and the
absolutely right. Yeah, of course.
qualifications that you've created. So the thing that we're talking about here is having conversations with data. And I'll be getting into a construct that I call query cube. And query cube is a process in adjudication. And one of the most important skills right now in the job market is adjudication. And that is judgment with information. In the essay that I've shared with you, one of the first things that it says is that we've often thought that having more data will give us better insights. But most of us know with some statistical background that by increasing our sample size, we do increase the sensitivity of our effects. But that does not mean that it's a large effect or a small effect unless we do a power estimation, right? So increasing our data does not necessarily improve the data, does it? Or our decision making?
Only if that data is correct.
It's garbage in, garbage out, isn't it?
Well, it depends. If you're thinking about data in terms of quantity of adding data points, not necessarily. But if you think about increasing the data as giving it breadth and depth, then we're talking about something different.
What does breadth and depth mean?
So, for example, when I'm thinking about like applied to AI, I can there's a difference between for me doing a search into whatever the AI was trained on or having a project and giving it all the documents that I need that have all the information for me to make the decision. So I'm giving it different points of view, like every single document is giving it like a different perspective, or even more much more nuance into the data, more specific context and things like that. So going into depth into each point of view, then when you're doing that, you're providing more. But the difference is that if you do give it to me as a human, then there's a theory that says that we actually don't have the capacity, the cognitive capacity to make that decision. Um, and I'm blanking on the theory and people know it, so just put it if you remember. It's the Kahneman theory. But I'm assuming that with AI, the AI wouldn't have that cognitive capacity limitation, right? That's
That's a good point. That's a good thing to bring forward. So what you're beginning to touch upon is and my background, by the way, is in embodied cognition. I got my PhD in 2011 from the Center for Cognitive Sciences. And I studied things like prior learning, prior experience, working memory, and decision making in comprehension as discourse processing. And I'm a mixed methods researcher. And one of the things that we're beginning to enter into is an area that I've explored over the years called distributed cognition. And the key here is that when we begin to look at AI, we begin to look at the immediate question, which is it really intelligence? Because it's got it in the brand, right? Or is it just a form of distributed cognition, which is a tool that complements us where we may have weak spots? But the question here is the really important one that you brought up, Gloria, which is that in some cases, we don't have the capacity or the bandwidth to process all this information, so we outsource. But this is not new to AI, is it?
No.
I mean, this is the basis for the abacus, the alphabet, the numerical system, glyphs on rocks, beaded necklaces for counting, and language. And in my own work, it's based upon the idea of we distribute cognition across the environment, relationships, language, and media in order to extend our memory and our processing. And in this case, what you're bringing up, Gloria, is that the AI, when used correctly, acts as a statistical lattice. It extends or complements us by creating much more working memory. Because oftentimes you can be thinking about something, have an amazing idea, and then forget where you started from, and then it's all gone. It's kind of like you were holding this wonderful idea in your hand, but it was all just sand. And then when the water came in, it washed out of your hands, and now you can't get it back from the ocean. What AI can do when used in the correct way is work as a complement. And Gloria, one of the things that I really liked about what you said is you're putting in data in order to work with it. And one of the cores to this today is what I call conversations with data. And conversations with data is really about the query cube process. And I'll bring forward a lot of the fallacies and the actions that we can take to really become efficient and optimize, and what we might call creating multiples of ourselves and living exponentially. And the idea is that I have never been more productive in my life. And being a neurodiverse person, I have found that this has compensated for things that have held me back for years. I mean, here I am, I have a PhD, I've had publications, but I'm also a high school dropout. I've had maybe a different road than a lot of people have into higher ed. And in a lot of ways, that's helped me. However, it's also one of those things where all of us have these types of obstacles that are personal to our lives. And as we begin to look at how we can use these tools, we may find that they are general enough to complement us in a way that allows us to act in multiples, allows our behavior to become exponentialized in order to increase our productivity, optimize our accuracy, and understand what's really going on. And one of the things that I really want to get into here is that this first set of myths is on the lexical level, right? It's the surface or the genre level. When we ask, say, for example, I'll show you a piece of work that I was on, and we can actually do this together if you like. Do you all have an AI open right now?
I'll get one, no problem.
Which one do you want?
Whichever one you like the best. What we do in class is we actually use all of them, and we've done a comparison on what's called semantic drift. And one of the things that we're going to be exploring here is that on the lexical level, on the surface or genre level, oftentimes we commit too early to coherence. We begin to let go of all the possible options that could help our approach to solving a problem. And that is, we commit too early to a solution. Anybody have experience with that? Seen it? Why is it that people commit so early to a solution?
I think for me, that's kind of what's caused a lot of issues, especially a little bit earlier on, where I always want to have one solution that solves most of my problems because I think free AI, that's kind of like what works best, right? Like you want to go to Target or Walmart or whatever, so that way you just have one stop, maybe two max to fulfill your needs. But in my experience, transferring that type of optimization has kind of had the opposite effect. Where I trusted one because I did research and it's like, okay, Perplexity or Claude are better than ChatGPT because I had so many issues. And it was fine at the beginning, but it as I get deeper into what I'm trying to do or more breadth, it seems to backfire after a while.
Why do you think that is?
I mean, hallucination's one of my biggest issues.
Well, let me ask you about this. If you ask a child, there are a number of things that we should unpack here, Nathan, and I like what you're saying. So first of all, oftentimes a lot of us respond to the lexical or the genre layer. It looks right, and we begin to attribute truth to authority because it begins to look like, for example, this is organized in a way that, for example, an expert on coffee mugs would talk about coffee mugs at Claremont University. And here are all the papers that support his work on coffee mugs. And we begin to see, oh, the AI has responded just like the professor on coffee mugs. And this looks like what I need. Secondly, we can attribute to authority because it cited all the things to Professor Coffee Mug and said, yes, well, I drew it from here. A third thing is many of the things that are happening with AI oftentimes are fixed within a week. So for example, last January in 2025, or January, a year ago, January, I was working with interns at Maitri, and we were doing work on one of my products and a literature review. And I said, now that we've begun to define the problem, who has done work in this area? And as we begin to ask the different AIs to pull forward these citations, the things that it would do would be called hallucination or confabulation. And in fact, in some cases, the citations looked so real that there were real professors with real titles similar to other things that they had published in journals that they had published in with real DOIs and real page numbers and real issue numbers. And I said, as part of our process, let's look these up. And why do I do this? It's because there is a tradition in psychology where people will plant fake citations in their work and in their bibliographies. And they do that to find out how many people are just taking things at face value and putting them in to have the authority feature that shows I've done the work. And oftentimes that's because I have compressed time, I have limited resources, I'm trusting that this person knows what they're doing, and this is what's expected. And oftentimes we're providing unearned trust based upon authority, right? And in many cases, we've seen repeated over and over in psychology. For example, in the Milgram psychology trials, where a graduate student was put into a room and asked questions and wired up. And a participant is in a control room with a dial, and they are told that every time the graduate student gives a wrong answer, they need to turn up the electricity and shock them. And they were told that this could be death delivering electricity. And many of them would do it, even though the graduate student was acting and feigning great pain. And oftentimes they attributed their ability to do this because somebody else was the authority and telling them to do it. So the fallacy of authority is a very strong bias that many of us rely upon for convenience, because oftentimes we don't have the bandwidth to go deeply on everything that we do. So at the surface level, we begin to see that what looks correct may not be correct because we're assuming conditionally that the work that an expert or a person who knows what they're doing, who can deliver good quality information, has been done. Now, should an LLM be able to do that? Because all it's really doing is predicting tokens, right? Not anymore. What an LLM does really well is what's called a semantic layer. And the semantic layer is actually the relationships that happen beneath the lexical layer. So for example, if at work you find out that there are going to be budget cuts, what are the relational and semantic connections between that message? They could be middle managers are going to be fighting for resources, employees are going to start expecting layoffs, other leaders are expecting that this leader is going to be leaving, which is why they're okaying the budget cuts. There are many implications that go along with that message, and many of us are attributing these without any evidence. And we are projecting what the meaning is through the relationships based upon the semantic world in which we exist. So everything that I've experienced leading up to this moment has led me to begin making predictions about what this phrase, we're going to have budget cuts, means to me and the organization at this moment. What LLMs do really well is understand that semantic layer, but they're not good at math. So why is it that these frontier models are now solving math equations that scientists have not been able to get close to?
Is it the semantics of logic?
Well, there is the semantics of logic, but there's something even easier, and they're called tool calls. So today's frontier models are no longer just LLMs. LLMs in many ways work as agents and orchestrators, and they're able to call up different tools to perform different functions. So for example, one of the fallacies of LLMs used to be, how many R's are there in strawberry? And everybody would laugh when it would say 2. But now the LLM says, oh, I'm not good at counting letters. I'm going to code up a little tool to count letters in Python in order to see how many R's are in the word strawberry until I actually have a repertoire of what the rule is here. Or I am going to create this Python script to do this multivariate analysis as mixed methods using R with these data sets that have been coded to do this. Or I am going to do these crosstabs with this qualitative data by calling up Python and creating this spreadsheet in order to organize the data. So in many ways, what the LLM is beginning to do is delegate into other programs and symbolic logic what it is not good at natively as a semantic layer. And that increases the likelihood that what we're doing is correct. And it brings us back to our idea of, do we trust what we outsource? And in many cases, we outsource so much every day. And many of the things that we assume are bad because it's an hallucination are also good. So for example, an LLM does exactly like a human being does. When I asked kindergartners, for example, what are the 4 seasons? The response was salt, pepper, Parmesan cheese, and popcorn, because I like popcorn on pizza. Say, oh, popcorn on pizza, that's delicious. Those are some good seasons. But have you heard of spring, winter, summer, and fall? Yes, I have. So what we find is that there are oftentimes many different cultural approaches to the context of meaning based upon how word is used. So one of my favorites used to be, what does a fire truck and a poem have in common, LLM? And it would come up with these ridiculous things and saying, oh my goodness, well, when there's a high alert people really get touched by it. And I said, no, they can both be read. But an LLM does not necessarily understand that's a homonym, because that's spoken prosodic language. But those are now cataloged in the semantic layer. The semantic layer, which is what LLMs are good at, are understanding the context of language in the forms of edges and nodes at different layers of the neural substrate in the neural network, especially the deep networks. So when we begin to look at an LLM, what we're really looking at is a very powerful semantic network. And what it's tuned to do is to help us construct meaning through relationship. But if we do a query such as LLM, let's do this together. What are subconscious biases? What are subconscious biases? Do you trust it? It looks right, doesn't it? Seems practical, common sense. There are some biases here that look familiar. But one of the things that Gloria said very early was that when she loads data, she tends to trust it a little bit more. Did I get that right, Gloria?
Yeah, because it's working with the same knowledge or the knowledge that I want to acquire from a specific source instead of whatever is trained on.
And what would be the problem of not using that constrained data set?
It can come up with things that are associated, but not necessarily what I want, not what I'm thinking about. Like I have seen the students maybe using, like you can tell that they're using AI because they're using theories in their assignments that we haven't talked about in class, for example.
Yeah,
So, like if I were a student, I would like load it up with the textbook and stuff like that to be able to answer an assignment, knowing that I'm using the same theories and the same models and the same frameworks that we're using in the class.
but on the converse, so first of all, what we're doing is we're constraining what it can pull from, right? Because these models
Exactly.
are trained on trillions of parameters of data,
Yes.
and even more because they're generating synthetic data, and all the human interactions are continuing to accumulate in these neural networks and developing new models from the old models. And in many cases, surprising us in what they can do and even surpass our own ability in some areas. However, there are still specializations where they have to make tool calls, such as in mathematics or symbolic reasoning, or certain things like homonyms. But when we begin to constrain the data set, it has much less to pull from, and the semantic network that it can draw from can identify sublevels or patterns in relationships between the concepts beneath the lexical or surface level. So, for example, when MIT decided that an antibiotic was the most pressing issue that we had in 2006, by 2017, we had developed a new antibiotic, the most powerful we've ever had, and it was called Halocin. And what had been happening is that many antibiotics were actually becoming immune, or many organisms were becoming immune to our antibiotics, and thus making us fearful that we could be wiped out by these viruses. So, what kind of antibiotic could we generate that they would not become immune to? And the quality of the data predicted the quality of the outcome after taking all the molecular structures, the atomic weight, and all of the characteristics of these organisms available to these scientists across multiple specialties. This was loaded into a high-powered symbolic logic AI, and it eventually came up with two models as candidates for antibiotics. One of them was shown to be immune or be capable of avoiding virus learning as immunity, and that was eventually called halicin. It was assumed or projected that having done this level of calculation would have taken 1,000 scientists 1,000 years to run all these numbers. So when we begin to think about this, what we're doing is we're outsourcing reasoning that may be beyond our own cognitive capability. And we create things like tools, rules, language, relationships, and objects in the environment, which we begin to name. And we come up with strategies such as mnemonic strategies of, okay, I'm going to remember this by thinking about putting LLMs in the butter tray of my refrigerator, and that's just the butter. Symbolic logic, I'm going to put in meat and cheese. Those mnemonic strategies help us to do chunking. Just like if I were to say to you, you have a digit span of 3 to 4. That means that you can hold 3 to 4 numbers in your memory at one time. What if I give you 16 numbers right now? Does anybody think that they could say them back to me? No?
No, not unless they were in order.
Yeah. How about this? 1492, 1942, 1776, 1976.
That makes sense. I can do a couple of those too.
What is it about that pattern of numbers that makes it easy to remember?
Yeah,
What,
grouping
what?
them on meaningful units. I think is 7 the max meaningful unit that you can have, or is 4? Oh, okay.
3 to 4. So why is it that we can remember those? Because each one of those is a date. So we can say 1492 is one number. Columbus sailed the ocean blue. 1942, the Second World War began. 1776, the American Revolution. 1976, the bicentennial. So those are actually just one number, a date, right? And what we're doing is we're chunking those into prior knowledge and associated mnemonics in order to be able to remember larger strings of information. And we do that through chunking, as well as distributing cognition by saying, for example, I like having a bookshelf because when I look at my books, and by the way, Gloria, I always look at people's bookshelves. I love that you have yours in the background. If I watch the news, I love interviews where they show people in front of their books. And then I'm like, oh, what should I read next? What are they reading? And one of the things that I love about that is I look at the books and it reminds me of what I read. And I thought, oh, I'd forgotten about that. And I'm reminded. And that is a cognitive placeholder for me. And what it does is it begins to tap into the relationships between other parts of my life and that symbolic trigger that says, oh, here is all the information that was in the book, The Master and Margarita by Mikhail Bulgakov. And I said, oh, I remember that strange cat with a Colt 45 that was working for the devil in Russia, which it's a strange book, but recommended. But these are cognitive placeholders. They're anchors. And what they allow us to do is distribute cognition. And when we begin to think about using AI, what we're really beginning to go into is complementarity. It's a specialized use of a tool or a resource in order to extend our own reasoning through semantic expansion. And it works that way in what's called a statistical lattice. And that is, I can hold a forest up and zoom in to see an individual tree. And within that, I can say, increase the saturation of light above this forest by 17%, retaining the unique color, shadow, and position of each tree, and zooming out to see the global effect. And I can go in and see the details of each tree and not lose anything. But yet I can still put in these global effects and understand not only the forest and the tree. And what that does is it begins to extend our working memory to allow us to deconstruct, explore, and analyze outsourced information that is too much for us to handle in our own heads as groups, as well as with common tools. For example, in early DNA research, my uncle worked at a company in Texas where they had to take all of the memory of the genetics, wheel it into a cart, and then plug it into massive processors. And in that sense, the movement of all that information is quite cost prohibitive, but we've become much more attuned to using these tools in order to become more efficient with them. And in many cases, my preference is actually to use my AI on my phone and the language, voice to text. And that's because of my neurodivergence, which is I have difficulty writing. So in that case, it's a wonderful way for me to work with text in ways that I was limited on in the past. So in this case, if we were to go from this very broad generalization and chunk a little bit and say, show me the biases of Hidden Brain book by chapter. So now what we're doing is we're qualifying the retrieval, saying, you know what, the boundaries on the data that I want are too broad. I'm going to constrain it now and calibrate to a much more unique data set so that I have more control over what I'm looking at, and I don't have to trust it as much. I can say, you know, this is something that I can look up. What are the actual hidden biases in this book? And what it's doing right now is a tool call. And you can see that on my screen, it's thinking. And I enable that in the background so I can see the conditional response that I'm getting in the thinking. And what's fun here is that up on top, I can actually tell my AI, I want instant answers right away because I'm impatient, or I want thinking, or I want pro. I only get so many pros a month with my subscription, but that goes deep. In fact, it can take several hours for it to do pro. In this case, though, it's kind of like what I do with consulting. When I go work for a company, I say there are 3 rates. The first rate is you want a simple answer without a lot of thinking. The second rate is you would like very good thinking and a very clear course through. In the third rate, I would like something that is absolutely true and can work for a lifetime. Those 3 different rates are similar to what we're seeing here. Do I want something quick and dirty? Do I want something that has had some conditional chain of reasoning responses and tool calls? Or do I want something like what produced the Halcyon antibiotic and have that real superpower of mass computing? And do I need it? And in those cases, we're using our adjudication or our judgment in making sense. Now what we've seen with the limited field of retrieval here, we can begin to qualify and say, okay, look at that. He's got some of these things, these biases. Can we trust this? Well, you can check it, but how about the book? Who did the research on these biases? Now what I'm starting to demonstrate, and we'll go through the query cube before we end, is conversations with data. And that is, once I've retrieved a certain data set, I can begin to question it and begin to paint it into corners. And the idea is that when it begins to come up, I interpret from the data set that I've retrieved and qualified. And I say, based upon what I've seen here, this doesn't look very current. And as a PhD, I say, You know what? I really can't look at research more than 3 years old. Otherwise, it's just kind of canonical legacy, and it's nice to point at the origins, but it's really not the current edge of research. So I'm not sure it's all that interesting except for legacy and history of psychology. And here we go. Who do we trust now? The book or the AI? And it's saying, no, these are not current researchers. And in fact, one of the problems here is that when we begin to look at the semantic networks underneath these, we see that the relationships over time begin to question this research in itself because it's not replicable. And the difficulty is that we're taking the lexical view of simple answers in serial presentation as textual or verbal format, when what we're really looking at are complex dynamic systems with elements that can interact through relationships in different ways over time and produce different effects within the same system. So when we cannot replicate, we may begin to understand that we have not qualified the retrieval boundaries of the system, and thus replication is different because our tools have gotten better, culture, language, society, and values have changed, as well as have the tools. So when we begin to look at this canonical research, we say, well, how much of it has changed? No, I don't spell check. And
Meaning,
I'm going from interpretation back into qualification, and I'm making it do another retrieval. Yeah, Gloria.
I was interested because I was asking Gemini the same questions that you are asking. And when I asked who did the research on these biases, it gave me an important note on the research at the end.
Yeah,
I put it on the chat saying since the book was published in 2010, some of the research Vedantam sites it has been in the middle of the replication crisis, basically.
we,
So it was like kind of like prompting that already without asking.
yeah, and those are some of the tool calls that are beginning to come forward now. For example, what I shared with you about January of 2025 pulling fake citations, that's popcorn and pizza. But now what it's doing is it's doing tool calls and saying, I'd like you to go into these academic databases and do searches based upon the semantic networks that are part of these databases now. And I'd like you to access these semantic networks and tell me about the relationships between these studies. And we get a much more in-depth analysis of these things than we ever have. But the problem oftentimes is that the information that we have about AI may be a month old. And in AI terms, that's like 100 years. Just like my dog, every year is 7 years. Every day is like 10 years in AI. It's amazing how quickly things move. And oftentimes we think that we're getting reliably one model, but we may be getting answers from multiple models within the same thread. And one of the things that we have to do is say, how do I make sure that we're getting the same model? Looks like we're at about 458. The last things that I want to say here are, we go from interpretation to inference. And inference is, how many different approaches can I test right now on this line of inquiry? And AI allows us to test many. And in fact, just like we could with a human being, we can with AI say, here are multiple inputs. If I observe the behavior, I can begin to infer the architecture of this model and then understand when models change and understand how to optimize and best use these models because of my knowledge of the output and the inputs. And this is the basis of cognitive science, understanding how stimulus impacts behavior based upon the history of the individual and the organism leading up to that moment of information processing. And it's through this, being able to hold open multiple inquiries until we're very sure that we've begun to understand an organism as earned understanding through experimentation and the role of emergence rather than just reduction, we can begin to develop interventions that we can begin to trust and replicate. So with that in mind, that begins with qualification, retrieval, interpretation, inference, and I'll say that again, keeping multiple inquiries open until you've absolutely eliminated them. And then intervention, which is, this looks like a thing that works. Let's start over and try it again. And we can continue to do this by refining our data, refining our questions, expanding our query, reducing our query. And the LLM is not just a prediction engine. It does the same type of hallucination that humans do with popcorn and pizza. And that is either a flaw or it's a benefit, especially if you like the creativity that LLMs can provide for you, which I really do. So I really appreciate you all hanging here with me. There's an essay that I've written that goes along with this. I do regret that we couldn't use the Fig Jam, and it would have allowed much more of you speaking rather than me. And but I'm glad to have shared some of what I've learned over the years about the evolution of AI as machine learning and some of the beauties of these new natural language processing interfaces that have really changed the world, and I hope will help us cure many more of the maladies that society continues to face as well as create for itself. Please do connect with me on LinkedIn. Please do set up an office hours visit. I love meeting people. I have virtual coffees all the time. I love hearing about your work. I love sharing mine. And I'd love it if you're interested in this class at some point. And in the class, what we do is we take AI tools and we actually build software so that we can test the ideas that we have in order to say, here's the intervention, here's the behavior, what is the architecture that informs it? And I think this is a lot of fun, working with Cursor, working with the frontier models, working with Codex, working with Google AI Studio, working with Figma, working with design tools. It's a super fun process. And also, if you're very psychologically minded, we go very deeply into what is intelligence and what does it mean when we begin to buy into a branded definition of intelligence in valuing our own unique insight into the world. And that's what I'd like to leave you with is, with these tools in science and methodical skepticism, it is our own internal experience utilizing these lenses that make us wonderful scientists. And I hope that we don't outsource that. It's natural that we will outsource, but perhaps with adjudication and earned understanding.
Thank you so much, Brock. Nathan, I saw that you had your hand up for a while. Did you still have your question?
Oh yeah, I was just I wanted to ask if you can repeat that list one more time, the qualification, retrieval, inference, intervention. I think I'm missing one step.
Just think of the acronym Query Cube. Q
Oh, okay.
R I to the third.
I to the third. Okay. That's really helpful.
Qualification, retrieval, interpretation, inference, intervention. And I have another paper on that. And this is something that we go in depth with in the class as well. And if you're interested, I'm actually building policy negotiation games for policy games for government, national service, as well as NGOs. And if you're interested in policy negotiation and language, this semantic layer is essential to understand. It's like opening a whole new world as far as understanding how to bring people together. It's beautiful.
Oh, yay. Okay. Everyone has ideally Brock's contact information to follow up on his offer for digital coffee. And thank you so much again, Brock, for this presentation. This was wonderful. We'll have it posted on our website and our YouTube in the next couple of days, so you should see it there by Monday. And
Take
thank
out
you.
take out all of the Figma fails. They might be mad.
I will. I'll edit that part out. Don't worry. Thank you,
And
everybody, for your participation.
it was wonderful. Thank
Thank
you.
you. Thank you so much, Brooke. That this was you're
Thanks,
giving
Brock.
me a lot of food for thought.
Yeah,
This is
thank
a lot
you.
to think.
Great stuff.
Let's keep the conversation going.
Yeah. Thank you.